Hi everyone. This is the continuation of deadlock. We have already seen what is on deadlock, the state where the resources are unavailable for the process is known as on deadlock, and for utilization of the resources there are three steps followed, that is request, use and release of that resources. We have already seen on that about this usage of resources and utilization in previous session. Now let's see what are the characterization of deadlock. For occurrence of deadlock, there are four main characterizations and conditions. In other words, let's see, if system holds these four conditions, then the occurrence of deadlock is more on that system. This is the scenario for these four conditions. In this, the first condition for deadlock is mutual exclusion. That is, only one process at a time can use that resource is the meaning for an mutual exclusion. Simultaneous access of that resource by more than one process is not allowed. But in that situation, if the same resource is requested by more than one process, at that time, obviously, only one process will get allocated with that resource. The other processes which request for that resource will be in a state of starvation or waiting. This is known as a deadlock state. Then the second condition is that hold and wait. In this, a process holding at least one resources is waiting to acquire additional resources held by the other process. This situation is known as hold and wait. That is nothing but a process. Let us consider a process is required more than 2 or 3 resources for computing the process and completing its work. In that situation, if the process needs for 3 resources and it is already holding 2 resources with itself, and it is waiting for another third resources which is already held by another process. In that situation, the third process are also not going to be get availed for this process, and the already holder two resources by this current process will also not be freed for other upcoming process which is requesting for those two resources. In that situation, that might be an more possibility of deadlock because it is already holding an resources and it is further waiting for another resources which is not currently available. This is a state where deadlock might occur. Then the third condition is that no preemption. We have already seen what is preemption and what is no preemption. In this, a no preemption is nothing but a resource can be released only voluntarily by the process holding it after the process has been completing its task entirely. That is, the process which is holding the resource can't be released in between the execution of the process. That resource will be released after completing the process entirely. This is known as no preemption. In the scenario, let us consider while a resource is getting held by a process and further next upcoming few processes are requesting for that resources, and the upcoming processes are of high priority. In that state, the already executing process which is of low priority will be holding that resources. In that situation, since the low priority process which is executing is in the state of no preemption, that the resource which was held by this low priority process can't be preempted. In this situation, the further processes which is requesting for that resources will be held in a deadlock state. Or else in another situation, for example, if this low priority process or whatever the process which is holding the resource and in an execution state and which is under no preemption, and it is waiting for another process which is held by which is waiting for another resource which is held by another process which is currently not being allocated for this current executing process. In that state also, the already executed resource are also can't be released because it is on non-preemption state, and the further request for that process are also can't be provided. So it will be entered into an infinite loop, and there will be an occurrence of deadlock. Then the fourth condition is that circular wait. The circular wait is nothing but one process will be holding a resource, and for completion of that it needs a resource which was held by an another process, and the next process, for example, let's see the take the first process as p0, and p0 is waiting for a resource which was held by a process p1, and the p1 is waiting for a resource which was held by a process p2, and p2 is waiting for a resource which was held by p3. Further it goes on, and again the last process pn will be waiting for the resource that was held by p0. So there is a formation of cycle in this. If a cycle gets formed in an process execution and the resource allocation, there is a compulsory occurrence of deadlock situation. So these are the four characterizations of deadlock occurrence. If these four condition is getting satisfied, then simultaneously we can say that the system will enter into an deadlock state.